Okay, so now we're going to get involved with exercise number 4, device installation. Let's first take a look at the drawings to see the added information. So right here, what we're going to be installing, as you can see, there's a symbol. This is for a duplex receptacle. That's the symbol you would see on the drawings. And the R right here is going to represent red in color for the actual device. So this device right here is also going to be a red duplex receptacle. And if you look here on the quad, the number sign signifies a quad. So when you see that on the drawings, you'll know that you'll be putting a 2-gain ring on the rough-in install and be installing 2 separate duplex receptacles. And the B stands for black in this instance. All right, let's go over the tools that we're going to be using on exercise 4 that are added to the ones we've already used. We got our contact voltage tester, GFI tester, what else we got? And lockout tagout procedure, which we'll go into more detail later on in the video. All right, so the first thing we're doing before we start this exercise, because we're involving energized parts at this point, is the lockout tagout procedure. So we're working on TCP1 circuit 1, so TCP1 being the panel, circuit 1 and 3 is the circuit breaker. So we have 2 separate lockout tagouts. This is to prevent anybody from accidentally turning on the circuit. So let's go ahead and open the door. So each lockout tagout has a key corresponding to the lock. Go ahead and open it up. This is for a single pole breaker. And this is your tag. So lockout, tagout. So circuit 1 is off, but so we can ensure no one turns it on, you unscrew this and put this on the breaker. Keep unscrewing it until you can get it on there. Tighten it up so it's on there, and this is when you would put your tag through the lock, close this, put the lock on, close the lock, take the key out. No one else should have this key except the person working on the circuit. If you were to put this on your cart and someone comes back from lunch and wants to work on this circuit, they might not think anyone's working on it because the key's laying out. So keep this on your person. And then the last thing you're going to do is put your name, T. Sickles, put your phone number. That way if someone needs to talk to you about when or how long it's going to be off, or anything. If someone needs to talk to you about why it's turned off, like the GC, they can call you. This is good, safe practice. And that's how you do lockout, tagout. Okay, so as you can see, we have circuits 1 and 3, both locked out and tagged out. So now we're safe to continue on this exercise. So this is our first device, which calls out to be a red duplex. First thing you're gonna do, pull out all your conductors. There goes the wire nut. So you want to make sure the first thing is the box is grounded and pigtailed properly, and as you can see it is. If you look in the box, there is a green screw inside, which we went over before, but if you want, you can take a look inside. There's a screw in there that the ground needs to be attached to, along with the in and out of the circuit. It all has to be tied together. Otherwise, you won't have a proper grounding system. It can lead to a very bad safety concern. All right, so now you're ready to test it with your voltage tester, because even though we got it locked out and tagged out, you always want to double check with the contact voltage tester. No power. If it were to have power, it would light up like a Christmas tree. Turn that off, save the batteries. So they spliced this through with wire nuts. So in order to properly attach this to the device, what I like to do is just cut them off. And then strip it. So you just go back like a little bit. Use leverage. Go with 12 wire, because this is 12 wire. So you go in the 12 wire selection on the wire strippers. Get that all taken care of. This particular device has little doors on there, so you don't have to hook them. So you can go ahead, and the silver screw is your neutral. So you would go ahead and put it behind the screw, just like that. Make sure it's not going through the front of the device. It's kind of a pain in the butt, but we'll get it. There you go. And I always like to use a flathead screwdriver. I don't want to over torque it with the drill or strip the screw out with the drill. That way you know you got it real tight. Okay, and you would turn it over, and you got the blacks, which is your hot conductor, and it's going to be your brass screw in this case. And the way you can always tell with a device which side is the hot, which side is not, is if you look at the prongs. The short blade is always going to be your hot. The longer one's always your neutral. And that the horizontal cutout on that indicates that it's a 20 amp receptacle, because you got some plugs that only have the horizontal. So that gives it a visible sign that you're dealing with a 20 amp receptacle as opposed to a 15 amp, which is just the straight, which you generally won't see on our job sites because we don't do anything less than 20 amps. Normally unless we're in a residential situation. So the ground, we're gonna have to hook it. So what you want to do is grab it with your wire strippers right at the end and just put a little hook on it to where we can actually attach it to this underneath the screw. Like that. I'm gonna unscrew it a little bit. All right, it's unscrewed all the way. Put it behind the screw. I need your thumb to keep it steady. All right, it's tight. Now at this point, a lot of guys will say to tape it, but you don't have to tape it. It's not required by code, so we decided as a company, we ain't gonna tape it, just saving time by not having to do it. At this point, you would use your drill to drill it right into the device plate. It's a 632 opening. Get it right on the hole. Now on a job, you would have drywall around this, so you wouldn't actually install these devices until after the drywall or whatever material is going to be the finished product. And that's how you install a device. Okay, so now we're going to go into the quad installation. As you can see, we got our grounds in the one black and one white. What I like to do is tie the two receptacles together like this first. So you got the white jumping over to the white, black jumping over to the black, so now they're connected. And then that way we don't have to have multiple wires going to the box. We can just attach to one device to energize both. But as you can see, we can't do that with the grounds. There's only one selection for the ground, so you're going to have two separate grounds attached, which you would splice onto the box ground and the ground coming from the cable itself. Okay, so there's two ways to do this. There's the old school way and the new school way. The old school is with twisting it, like in using a wire nut, which is the most, I believe, is the most safest, because you're actually twisting the wires together instead of it, being stabbed into a port Wago, which could come out if you push too much wires in the box. So you would just strip them all, get them all lined up, and just lightly get them to go into the same groove with each other. And then once they start getting in the groove, then you go a little bit tighter. And at that point, you would apply your wire nut. All right. Okay, so now that we got our grounds done and pushed in with our pigtail splice, we only need to attach to one device, remember, because the other side's already been done connecting to the other one. So you would just take your white, and with these particular devices, they don't have the flap door, so you're gonna actually have to take your pliers or your wire strippers and put a hook on the end of the wire so you can put it under the screw like so. And you always want to put the hook going the direction that you're going to be spinning the wire. So when you tighten it up, you know, it goes with the loop. It's going to draw it in tighter. So let me show you. If you go the opposite way, which is not the right way, when you put it on there, you're actually spinning the hook out. So once you get it tight, you could feasibly take the hook off of the screw. So you always want to put it the way that it will tighten this, the loop around the device. So as you tighten it, it draws it in closer. It gives it a more secure connection. So we'll do the same thing with the other side on the black. Make your hook. Just grab the wire right at the end. Do yourself a nice little hook. You don't want to make it too tight to where you can't get it around the screw. Put it in the direction we had just talked about. And then tighten her down. Okay, at this point now we're ready to attach it to the box. All right, so now that we got the devices installed, we're going to go ahead and go to the junction boxes to make sure we got the proper circuits tied onto the feed coming from the panel. Okay, so the first thing you want to do is make sure you have a continuous ground fault current path, which means all the grounds need to be connected from the panel throughout your whole circuit. Right now, there's a ground bar that's installed in this junction to accommodate for all the grounds associated with all circuits. Line in and line out to your load. So I'll go ahead and attach that to the ground bar. The reason for your grounds, in a nutshell, is in case of a ground fault, it will trip the breaker to de-energize the circuit. Otherwise, if there's metal contact or some sort of issue with the device, if it doesn't have a proper ground, it will just stay live and could very well cause a very big safety concern. So now we're in the junction. Circuit 1 and 3 is off, but we have other circuits in this box, so you want to take your voltage tester, make sure nothing else is energized in this box. Otherwise, you're going to have to get your foreman or accumulator to make sure this box is completely de-energized before you work in it. All right, so look at the labels. Circuit 1, it's labeled on the cable. You're going to find your neutral and hot corresponding to circuit 1. So right there. So go ahead and open your flap door on your Wago for the white. Go ahead and stab it in. For your white, close the door. That's your white for circuit 1. Go to the black, open your door, close the door. So now you're ready to energize that one. Let's push that one back up in the box. So now we got circuit 3, which is the red, and then we'll attach our wires. So black would go with red because that's the hot color. And then white, that's your neutral. Goes into the white selection there. All right, doors are closed. Let's push them back up in the box. All right, let's go ahead and energize these circuits and take the lockout tagout off. Okay, so now that we've finished the devices and checked the area to make sure it's clear, now it's safe to take the lockout tagout off the circuits that we had worked on. So the person who actually installed it should have the key. Go ahead and take it off one by one. Go ahead and take it off. And what I like to do is go ahead and just put it back together. It's because these keys get mixed up, they all look the same. You want to make sure you either label the key with a number book or make sure you put it right back on, because otherwise it's a hot mess trying to find the key for each lock, because you can have multiple on a job site for different panels. So that was the first one. Take the lock off circuit 1, go ahead and unscrew it, put it directly back on the lockout tagout device. Leave the key inside, and you can see here it's actually labeled 2. This is labeled 2. You can do it in numerous different ways with tape. I like to use the numbers book. That's and then keep them all in one location. So let's go ahead and energize these circuits. Okay, now that we're ready to energize, common practice is, when you go to turn it on, don't look directly at the panel, even though it might be completely safe. Definitely want to just look away. Circuit 3, look away. I know it seems like it's not a big deal, but for some reason, if it were to arc, at least you'd be covered with your face facing away, and make sure you have your proper eyewear on. Okay, let's go check our devices. Okay, let's check it out. So we're going to use our GFCI tester. And as you can see, the 2 lights on the right light up, which signify that the wiring is correct. So if you follow the wiring, it's going up just like the draw lines call for. Goes to the second one, jumps over. Wiring is correct. Okay. Let's go to the quads up top. This is circuit 3. We have a correct indicator, correct indicator. So At this point, we just know they're all energized, but we have two circuits here, so we want to do another test to make sure they're on the right circuit. So what we're going to do is we're going to de-energize one of them and make sure that it de-energized the correct circuit. All right, let's go ahead and de-energize circuit 1. Okay, we've de-energized circuit 1, but we want to see if circuit 3 is still energized to make sure it's not swapped. So circuit 3 is the red receptacles, which they are still lit. And displaying the correct indicator. So we turned off circuit 1, which is the quad, which is off, which is good. That means it's wired correctly. That concludes the first part of our wall exercise rough-in, exercises 1 through 4.